students, now we shall see the next numerical on real gases. Calculate the pressure of 3 mole of air at 300 Kelvin with a total volume of 0.8 meter cube. Use the ideal gas law and the Vander Waals equation of state. So here we have to find out the pressure of air, 3 moles of air at a temperature of 300 Kelvin and the volume is 0.8 meter cube by using two things. One is ideal gas equation and second is Vander Waals equation. Okay, so first we will go by the Vander Waals equation. We know that the molar specific volume V bar is equal to V divided by N. Capital V is volume, N is the number of moles. So volume is given as 0.8 meter cube and N is given as 3. So you get V bar is equal to 0.267 meter cube per kg mole. This is molar volume. Now we have to find out the for Vander Waals equation there are two constants A and B, and here it is air. So we will find out the Vander Waals constants A and B from the table. So this is the table for Vander Waals equation of state. In your thermodynamic data book, these are all available. These whatever constants are there for Vander Waals equation or critical temperature, pressure, and critical properties like, and third is the Beatty-Bridgman constant. These are all available in the thermodynamic data book, and this data book is allowed for your examinations. Now you take the case of air. First row itself is air. Okay, first row you can see is for air here. Air, the volume of value of A is 135.8 and value of B is 0.0365. So we will use this value as 135 and 0.0365 in the Vander Waals equation of state. So you can see here the A value is written as 135.8 and B value is written as 0.0364. Now using the Vander Waals equation for state, we know that P is equal to R bar T divided by V bar minus B minus A divided by V bar square. Substituting the values like R bar is 8.3143, that is the universal gas constant, into T is given as 300 K. So directly we are taken, it is given in Kelvin, divided by V bar. V bar we are calculated as 0.267, the molar specific volume, minus B, the constant is 0.0364. This constant is taken from the table for Vander Waals constants, minus A is 135.8 divided by V bar square is 0.0267 square. So solving this equation, we will get P is equal to 8.92 megapascals. So this is the value of the pressure if we calculate using the Vander Waals equation of state, which is for real gas. But if you are using for ideal gas equation, now we will go for ideal gas equation. PV is equal to nRT. Okay, so P is equal to nRT divided by V. So N number of moles is given as 3 into R bar is 8.314 into T is 300 Kelvin divided by V, that is 0.8 meter cube. We found this pressure as 9.35 megapascals. So we can see that in ideal gas equation, the pressure which is showing is 9.35 megapascal, which is different from the Vander Waals equation of state, which is for real gas. We find this as 8.92. So this is how you solve the problem using Vander Waals equation as well as ideal gas law. And when we have solved the Vander Waals equation, what we have done, we have taken first we have calculated the molar specific volume, that is V bar is equal to capital V divided by N. We found the V bar. Then we found the A and B from the Vander Waals constant tables, which are directly available. Substituting the value of A, B, V bar, R bar and T, we get the P. So this is how we have calculated the P pressure. And now for ideal gas, it is straight. PV is equal to nRT, and substituting the values, we found out the value of P. This is how you can solve for pressures using ideal gas equation as well as Vander Waals equation for state.